Hi everyone. In today's lesson, we're going to talk about how to take the derivative using the chain rule. The chain rule most likely includes an inside function and an outside function. And we take the derivative of the outside function and then we actually multiply it by taking the derivative of the inside function. So let's do an example first. So here's our first one, f of x. So I want you to pretend like this is f of x equals x to the sixth, where x is this inside function. So if I were to take the derivative of that, we learned the power rule is we take the 6, drop it in front, keep the x, and drop the power down by 1 to 5. So we're going to do the same thing. So we're going to say f prime is where we take the 6, drop it all the way in front, keep the base or the stuff inside the parentheses, and then drop the power down by 1. But because of this inside function not just being x, we actually now have to take the derivative of the inside. So my inside function is negative 3x plus 5, and if I want to take the derivative of that, we'll use the power rule. So take the 2, multiply it by the negative 3, that gives us negative 6x, drop the power down by 1, and then the derivative of a constant is 0. So it would be negative 6x to the first times all of this. Now we can clean this up a little bit if we'd like. So this could be f prime of x, because this 6 is attached to this by multiplication, so we can combine the 6 and the negative 6x by multiplication and make that negative 36x, put that in front, negative 3x squared plus 5 to the fifth. And that would be our derivative. All right, let's try another example. So example number 2, same concept, except now we have a negative 5 on the outside. So I want you to treat this as if it is f of x equals x to the negative 5. So what you would do is the derivative of that, bring the negative 5 in front, keep the base, keep the x, and decrease the power by 1. So negative 5 minus 1 is negative 6, right? We're subtracting. So the concept here is the same. F prime of x, we take the negative 5, bring it in front. This is your base that you're going to keep the same. So 6x squared minus 4x plus 1. And we're going to decrease the power by 1, which gives us negative 6. And like we did before, we have to now, since we have more than just one thing in here, we need to take the derivative of the inside and multiply it. So the derivative of 6x squared, we take the 2, bring it in front, and multiply it with the 6. That gives us 12. Keep the x, decrease the power by 1. The derivative of negative 4x is just negative 4. And then the derivative of a constant, 1, is 0. Now, because there's more than one term here, we have to multiply it. So we have to put it all in parentheses. So it's technically the answer is negative 5 times 6x squared minus 4x plus 1 to the negative 6 times this. Now, this one's not as easy to multiply like this one was up here, so you theoretically can just leave this as your final answer, and that would be accepted. You just have to be careful that you put this piece in parentheses. So this would be your final answer. All right, let's try another one. So the concept here is the same, except now we have a fractional exponent. So again, treat this just like you would if you had f of x equals x to the 1/2, and you wanted to take the derivative. Bring the 1/2 in front, keep the base, and subtract the power by 1. So 1/2 minus 1 is negative 1/2. So same thing here. My f prime, we're going to take the exponent, bring it in front. We get 1/2 x squared minus 4. Keep the base and subtract the power by 1. So 1/2 minus 1 is negative 1/2. And we have to remember to take the derivative of the inside. So the derivative of x squared is 2x. Take the 2, bring it in front, keep the base, drop a power down by 1. and the derivative of this constant is 0. So we don't need to write that. Now, we can leave this as my final answer, or we can kind of clean it up a little bit. So let's say our derivative, f prime of x, if I multiply a half times 2x, well, a half times 2 is just 1. So we could say this is 1x, x squared minus 4 to the negative 1/2. If we wanted to clean this up even more, if we wanted to, we could say that it's x on top and x squared minus 4 to the positive 1/2 on bottom. I'm just taking a negative exponent, bringing it downstairs. And if I wanted to change this into a radical, we could say the derivative is x over the square root of x squared minus 4. Now, you won't have to do that. It's just good practice to try with your algebra skills. So this answer up here would have been totally fine. Okay? All right, here are your answers. Just a couple things to note about the first one is that when you bring the power in front and then reduce the exponent, when you take the derivative of the inside, it's more than one term, so we're going to need parentheses around it. If you don't have the parentheses, it's technically not the right answer, so make sure you have that around this piece. Here's the answer for number 2. So same thing, we brought the exponent in front, kept the base, decreased it by 1. Be careful, negative 4 minus 1 is negative 5. And then took the derivative of the inside function to be 5x to the 4th plus 2. Again, making sure you have parentheses around that. And then the answer to number 3, we take the fraction, bring it in front, keep the base, decrease the exponent by 1. Remember that 3 halves minus 2 halves, or 1, is 1/2. And taking the derivative of the inside, it needs to be in parentheses because there's more than one term as well. All right, here's your answer to number 4. First thing I did was take the cube root and make it a 1/3 power. Then bring the 1/3 in front, keep the base the same, decrease the power by 1. And then I took the derivative of the inside. You could take it a step further and simplify, but I'm going to leave it just like that this is your final answer. If you have any questions on these, I'd be happy to go over them tomorrow in class. You do not have to finish 5 and 6 for homework. We will just leave it like that, okay? All right, have a great night, everyone.